Hello, good day everyone. Welcome to my YouTube channel, the PD Casting TV. Don't forget to click subscribe and ring the bell button. You can also put some comments for our discussion this afternoon. So for today, we are going to take up about derivatives or the differential equations. So I will share to you now about the derivatives. So the definition of the derivative. The derivative of a function f of x denoted by f prime of x or f apostrophe x is the function if prime of x, this is the derivative of x, is equal to the limit of f of x plus delta x minus f of x all over delta x, where our delta x approaches to 0. It is defined at all points x in the domain of f where the limit exists. So meaning our original function x, we are going to plus the delta x minus the original function x over the delta x. Okay. Remarks, there may be points x sub o, in which is the element of the domain of f, at which the f prime of x sub o does not exist. So the domain f prime or the derivative is the subset, or that is the set for the domain of f, or can be seen in the domain of f. So the definition tells us that the f prime of x sub o, or the f prime of the initial x, is the slope of the tangent line to the graph of the function at point P. Our point P, we have x sub o and the function x of f of x sub o. So to get the derivative of f at x equals x sub o, we use this definition or this equation. F prime of x sub o is equal to the limit of f of x sub o plus delta x minus f of x sub o all over the delta x. Again, our delta x will be set or approaches to 0. Alternatively, by setting delta x is equal to x minus x sub o, we can get f prime of x sub o is equal, or the derivative of x sub o is equal to the limit of f of x minus f of x sub o over x minus x sub o, in which our x approaches to x sub o. Other notations for the derivative, we can have y prime if y is equal to f of x. Again, y can be written as f of x. Or it is dy over dx, or it could be d over dx. These are the derivatives of f of x, the given function. So we can have d over d of x of the given function, or we can also write d of x or d sub x of f of x. So these are the different notations of the derivatives. Again, the derivative can be written as y prime if y equals f of x, or it could be dy over dx, d over dx of the given function f of x, or the capital D of x or d sub x of f of x. The process of computing the derivative is called the differentiation. So again, in computing the derivative, this process is called the differentiation. So let's now have an example. Find the derivative of f of x equals the square root of x. So for our solution using the definition, we have if prime of x is equal to the limit of, since we have the given square root of x, so we can have square root of x plus delta x. So includes the 2 minus the square root of x, which is our original given x, or square root of x, the given function, all over the delta x. Again, this is from our definition. So we just follow, since our x here has the square root, so you put the square root here, square root of x plus delta x minus the square root of x, where our delta x approaches to 0. So to simplify further, we can have the limit of the square root of x plus delta x minus square root of x over delta x can be multiplied by the conjugation. We are going to conjugate the numerator, which is the square root of x plus delta x. Since we have here minus, you just change this sign into plus. So you can have, as you can see, you just copy here the square root of x plus delta x, you just change plus here since we have minus sign plus square root of x. Whatever is the given conjugation, it should be written also in the denominator. That is the square root of x plus delta x plus square root of x. This is by conjugating the given here function. Then same, we have here the original denominator of delta x, just have to put. Then delta x approaches to 0. To simplify further, so this will become, since our square root times the square root, it will become eliminated. So you just copy x plus delta x. Okay, x plus delta x minus square root of x times the square root of x again. That is square root of x squared. Since square root and squared can be eliminated because of the exponent 2, so the remaining is x. All over the delta x here multiplied by each of these. So you have here the quantity, you just copy here the denominator, the square root of x plus delta x plus the square root of x. Then to simplify, this will become 1. Why is it 1? Okay, let's go back here. Since we have here x minus x, this will become 0. Since we have delta x here, the remaining is delta x divided by delta x. So delta x divided by delta x, that is equal to 1. That is why it becomes 1 here. Then you just copy the remaining denominator, which is the square root of x plus delta x plus the square root of x, in which our delta x approaches to 0. So therefore, since our delta x is 0, so this will become 0 here, delta x 0. You just copy the numerator 1 over square root of x plus square root of x, that is 2 square root of x. Therefore, our f prime of x is equal to 1 over 2 square root of x, or the derivative of square root of x is equal to 1 over 2 square root of x.